Okay. So finding the middle node of a linked list is again a simple thing. It's not complex. Just you have to know this beforehand. You can also think of this in an interview as well. It's okay. Let me create a large array like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 9 is pointing to. Okay. We don't have to talk about tail pointer after this. In generally in lead code and geeks for geeks, if you're solving, they don't provide you with null. They don't provide you with tail. So you will have to do with what you have. So they will only give you head, and the questions that you will be solving is only with using head. In case you are sitting in an interview, you're solving a new problem and you think that tail might help here, you can ask your interviewer that, okay, I want to use the concept of tail here. If he allows it, feel free to do that, because that will significantly reduce your time complexity of the solution. Okay, so be on the lookout for that. And now let me tell you how to find the middle element. So what is the middle element in this case? 4 elements here, 4 elements there. This is the middle element, right? 5. How can I find it?
Take the 2 pointers. One is first pointer and slow pointer. First pointer, every time it rotates to next node. The slow pointer moves only one node. Exactly. At the end of the first pointer null, it reaches to null. Slow pointer will at the middle node.
Okay. No, you're right. Absolutely right. That is the optimized way of doing it. But let's first talk about the brute force way, the basic way. The basic way of solving this is very simple. Count the number of nodes. Okay. So how many nodes are there? 9. You just now told me that you know how to count the nodes, the linked list. So that's good. 9 nodes you know. Then what is 9 by 2? It's 4. Exactly. So then traverse, like come to head again and traverse 1 node, 2 node, 3 node, 4 node. And as soon as you come to the 5th node, you will stop. Okay. This is how you can do it. Okay. Now, in this case, you have to travel the linked list twice. First time to count the node, and second time it's n by 2, but it's actually n, like we ignore the constants. So this is O of n, but it's a 2-pass approach. How to do it in one pass? It's the same way that Kashi just mentioned. Take 2 pointers. One is a slow pointer, one is a fast pointer. Okay. The fast pointer will move 2 steps ahead, okay, at once, and the slow pointer will move only 1 step ahead. So see, if someone goes twice the speed of what you go, for example, it's a race, you are standing, your friend is standing, you can run twice the speed of your friend. If this is a 10-kilometer track, okay, if this is a 10-kilometer track, by the time you reach here, what distance will your friend would have covered? It's 5 kilometers, right? It's obvious, because you are running at the speed twice of what he's running. If he's running at let's say 10 kilometers per hour, you are running at 20 kilometers per hour. Okay, just making up examples here. Okay, so similar logic is presented here. So slow will move 1 step. Okay. Fast will move 2 steps. Slow will move again 1 step. Fast will move 2 steps. Slow will again move 1 step. Fast will move 2 steps. Slow will again move 1 step. Fast will move steps. Now, can fast move 2 more steps? He cannot, right? Fast cannot move 2 steps. In that case, what will happen? This particular, wherever your slow is present, is your answer, is your middle element. I'm hoping no one has a doubt in understanding this. It's fairly straightforward. So let me show you the code for that. Like, I can write it as well, like that's fine. Let's say S is equal to F is equal to head. Okay. Basically slow and fast, both I'm pointing to head. And then what am I doing? So see, there are 2 versions of this code. Okay. Both versions are acceptable. It just depends which particular element you want. For example, you will run this loop till fast is there, like fast is not equal to null, and fast dot next is not equal to null. Okay, you will do slow is equal to slow dot next, fast is equal to fast dot next dot next. Okay, this is basically what the question is, what the question says. So slow and fast, you both pointed it at head, and then you ran it this way. You will check basically is fast is there. So at this particular position, why did you stop? Fast is not equal to null, right? So this condition does not satisfy. But this condition, fast dot next, is null, right? Fast dot next is null. So for that particular case, you will stop this for loop. Okay? There is one more similar case where you do while fast dot next and fast dot next next. And do the same thing. Both cases are relevant. Both cases have its own merits and demerits. Not demerits and merits. It's basically how you want to manipulate your code. So basically, let me show you what I'm saying in this case. Let me take an even length, array here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Slow here, fast here. Fast moves 2 places, slow moves 1 place. Fast moves 2 places, slow moves 1 place. Fast moves 2 places, slow moves 1 place. Now see, your fast is at this position, your slow is at this position. Take care. If you use this one, fast dot next and fast dot next next, then in that case, you will stop your loop right here at this particular point, right? Who didn't understood this? Like if you are using that particular condition, if you are using this condition, the second one, then you will stop right here. In that case, this becomes your middle element, 4. But if you follow this one, while fast and